Hello, everyone. Glad to be here. This talk is called Narrative-Driven Generation, where we're going to use large language models to turn a story into a game. I'm Rachel. I'm a research scientist at Riot Games and focusing on generative AI, and we're interested to explore how generative AI can help game development to unlock new capabilities and experiences. So as many of you know, that large language models are gaining tremendous attention now, thanks to their ability to understand and produce human language across a wide range of tasks, including answering questions, summarizing text, or even more complex problem solving. And of course, we also start to see more applications in games where people try to plug it into a game and just, in whatever way possible, just to see what happens. And then we start to see videos like this.
I'm pressing activate on this pedestal and nothing is happening.
Maybe it's because the pedestal doesn't find you very impressive.
You didn't have to do me like that. Look at that pose. Are you pretending to surf?
You caught me in the middle of my secret surfer training. Gotta ride those waves even in the midst of battle, you know?
I do know.
So it is entertaining to watch, and there's some novelties in it. But to be honest, it's not perfect, and sometimes it does things that doesn't really make sense, and sometimes it can be very broken. So real question becomes, how can this be actually useful in practice, and how to do that? So to answer that question, there are a few things that LLM is really good at that makes them can be useful in games. So for example, the first one, the ability to understand complex structures and patterns. So for example, if you're dealing with a game that has a screen like this, where 1,000 different things are happening at the same time, all affecting each other, it is difficult to write a system that can process that. But LLM is pretty good at taking a long text input, extracting information and reason about it to understand what is going on. And then it is able to process and generate text that is contextually and semantically rich. So for example, here's a screenshot from the game called Disco Elysium, which is known for its very extensive dialogue system. It's very well written and very engaging. And to achieve something like this, you need good writers and a very carefully crafted storyboard to put that all information together. But LLM has the potential to achieve something like this with a lot less human effort. And then last but not least, because language models are trained on data gathered across the whole internet, they have these knowledge, or we say common sense, built in and can reason through it. And this is interesting because now the generated output has some kind of intention or meaning associated with it. So we see these funny screenshots from Skyrim, where people put a bucket on NPC's head, trying to trick them and steal their stuff. So it is almost impossible to script an reaction for every single possible behaviors like this. But LLM can look at this and say, if someone put a bucket on your head, it's probably not very polite, and then so I'm gonna get mad at you. So today we're digging into the use of LLMs for content generation, and we try to push as far as we can. We're not just generating a story, not just a dialogue, we're trying to generate an entire game. And to give you an idea, here's a preview of what we'll see at the end. So some of you being skeptical might think, if you just look at a result, I can probably achieve something similar with procedure generation, which is probably true, as we already see how powerful it is as a content generation tool. We use it to generate maps, to generate game histories. We use it to generate pretty much anything you can imagine in the game. So on high level, procedural generation, or PCG, is a powerful way to create dynamic content using algorithms instead of manually, by designing a system to mimic how an expert would do it. So that usually requires substantial domain knowledge and can be very time consuming. And it's also not trivial because a lot of the problems involves much more implicit knowledge about how humans look at these problems than we thought. But LLM has some level of these knowledge already built in, and it has the ability to simulate how we look at these problems. So let's make some very different tools that are good at different things. So for example, Minecraft here, LLM is probably has more knowledge about how villagers interact with each other, while PCG is much more efficient, like things like generating different shapes of trees. And then to create dynamic content or emergent behaviors, in procedural generation, you don't design the behavior itself, you design these objects and systems and the rules that binds them together. So for example, he's given like characters, weapons, personality, and the arrows is how they interact with each other. And the more independent system you have, the more emergent or interesting behavior you get. Because they're all connected to each other, if you want to add one thing into the game, you need to touch everything. And as the system grows bigger and more complicated, it can start to become intractable, and then you start to get weird behaviors. But on the other hand, with LLM, introducing a new attribute can be as simple as adding an extra field in the prompt. And LLM acts like this black box, just takes all these information and processes them as a whole. So to decide what happens next about reasoning instead of scripting. So in that way, while you give us some granular control of how things exactly works, it strikes a better balance between coherence and the varieties of how many things you can have in the game and the development time. So just like any other generation techniques, LLM is not a magic solution. And in fact, working with LLM involves much more than just generating text from the prompt. So there are some architectural patterns around how to best leverage them and apply it to your game, and that's what we're going to talk about now. So first, everything starts with story. So LLM is very good at generating narratives because fundamentally it is trained to do so. So you can imagine it's like a near infinite story generator which when you prompt something, it gives you something unique, diverse, unpredictable, which can be very handy when it comes to replayability. But is it a good story generator specifically for your game? Because a system that can simply spit out a bunch of text is not very helpful. And in order for that output to be useful, it needs to fit in the context of the game. So here, when we talk about story, we're talking about everything that happens in a game, including background story, events, branching, quests, etc. And they all need to be grounded in the game. So first, you need to define the elements in the game, which is the nouns in the game, like how many characters, who they are, what the story is about, and you need to be specific about it so that LLM has these necessary building blocks to work with. And after that, you need to generate the progression, which is the verbs in the game. So here, one thing I want to call out is the game mechanics is actually part of the story design here, because these gameplay verbs dictate the world logic and how the character behaves. So for example, telling a story about combat adventure is very different from telling a story for example, farming in a cozy village or a love triangle story. So it is important that LLM understand these mechanics. And then what you do is you just grab all the information, relevant information in the game, like player choice, the game state, the history, along with the mechanics, and feed it to LLM, say, generate something I want, and it can be quests or events or anything in the game. And these information can come from any point of the game. It can be like at the start of the game, it can be in the middle of the game, which means this enables us to do dynamic story generation or branching, and gives us the ability to embrace any branch of the history. So if we look at how dynamic quests and events are typically done, they usually fall into one of the categories. Here, one is plot-centric, where you design a structured plot and everything is carefully planned and to be engaging, but they have very limited flexibility to respond to player-driven action. And on the other hand, we have simulation-centric, like Dwarf Fortress, where you have great freedom to respond to player spontaneity, but there's no enforcement of author's story arc. So how LLM How LLM does this creates this nice middle ground of where you can tell it where the story should go, but because it's still considered a player choice in game state, it can still maintain some degree of flexibility and dynamism there. And then after we have the story, we need to generate the world from the story, which is generate maps, locations, items grounded in the story. And being able to generate a game world from narratives means that we are able to do world creation on the fly as the story progresses. And here's an interesting paper that came out earlier this year called Word to World. Their goal is to generate a fully playable 2D maps from a short story. So what they did is first they generated a short narrative with a short story, and then combined with this predefined sets of tile assets, which can be character, can be background, can be items. And they asked LLM to generate an array of symbols, each correspond to a position on the map and which tile to place on top of it. And then after that, they use algorithms like A-star pathfinding or LLM as a judge to evaluate the quality of the map, and then take that feedback, regenerate the map, and iterate until you get something satisfying. And on the side, you can see the results there. Each of them is like quite coherent on itself, and then you can see each of them has very different theme. So that is interesting, because now you can just take a story and generate a world. But you can see a few limitations here. So for example, this doesn't really generate well when you have a super huge map. While LLM have some sort of, some sense of a spatial relationship, it's far from reliable. So it can do pretty poorly at things like scattering things around the map in a coherent and a logical way. So it actually relies pretty heavily on using algorithm checks to do things like checking a reachable area or unreachable items or minimum path from the start to the destination. And then so you might be wondering, then why is LLM still valuable here? Because we can already do so much better with procedure generation. So procedural map generation is great at generating a big map with custom elements, like different biomes, different geography, plants, animals. But if you look at it closely, it can become a bit repeated and uninteresting very quickly because everything follows the same pattern. So take this game as an example. This is a game that came out this year called Shadow of Doubts. It's a procedural generated detective game that has a fully simulated city and NPCs, and each of them has a home, they have a workplace to go to work, and there's restaurants and there's shops, and then everything you see, you can interact with it. So this gives player a city full of things to explore, which make it super interesting gameplay. But if you play for a while, you start to notice the apartment all looks kind of similar, you know, the same furniture, the same setup. The building's also kind of similar, it's the same layouts, and the restaurant's not so different than each other. And this is where LLM can be very valuable to add that touch of personalized design. So for example, you can take this and say, this is an apartment of a middle-aged single man whose life is a mess, has gambling issues, and then generate his apartment. And then you can say something like, oh yeah, this person has a minimal setup of a mattress on the floor and a box of beer, that's it. And then you take that output and create back to your generations pipeline and say, put those on the map and then fill out the rest. And in that way, the generated world feels a lot more tailored to the character, it has a lot more personality, and the items around you have some sort of meanings that binds the character, the world, and the story together. And then finally, characters. So I'm going to jump straight into this paper because it's perfectly showcase how the LLM's potential in driving NPC behaviors. So for people who hasn't seen it before, this is called Generative Agents, inspired by The Sims, where they've created a village of 20-something people in it, and they each have a different background, different personality, and they have relationship with each other. They can interact with each other or interact with the world. And how they, all of them are driven by LLM instead of scripting. And how they did this is by introducing a memory stream, which is a series of events representing in natural language text. So for example, I just saw this person, I did this thing, I went to this place. It's just pretty much like how we observe the world. And then, so they perceive the world, they put it in their memory, and then when they're ready to do something, they retrieve the relevant memory from their memory stream, and they can either do planning, which is decide what I'm gonna do next, or they can do reflection, which is taking multiple events and then do a higher level summary or high level thinking. And then taking the generated action and they feed it back to the environment and then receive new events and then repeat that process. And a famous example in the paper is that they seeded one of the character with this thinking. of I'm going to do a Valentine's Day party at this place at this time. And without doing anything else, this person starts to talk about it with people she met, and then these people start to spread the words even further. And then so now everyone knows about it, and some people start to spontaneously do things like arranging an event, decorating the place, or inviting people they like because it is Valentine's Day. And then on that day, people spontaneously showed up and they had the event together, which by only seeding one of the character with this event memory say, I want to do this party. So a few key points here we can see. First, they can perceive and react to the world similar way to how human player does. And everything that happens goes into their memory. That makes everything happen in the world has a real impact on them. So a common case in the game is if you attack or insult an NPC in the game and you run away immediately, if you get far away, you get away from it. And when you come back, it's like nothing happened. But that's not the case anymore if an NPC now have memory and everything happened to them has a real impact on their behavior. And second, they can maintain a complex relationship. So relationships in the game is most commonly represented as a score, simply says how friendly you are with this person. And also a lot of time, a common abuse that player does is simply repeat an action that boosts the score. So for example, you can say, I kiss a character in the game for 1,000 times, now they want to go on the date with me, which is simply not how human works. We form a relationship like shared memories or common experiences, and that's exactly what the memory stream is doing here. So that enabled us to do something like, say, for example, this character is my mom. I love her very deeply, but recently she's been yelling at me a lot, and then we're having a fight. That doesn't make us enemies, though. That doesn't decrease the score in any sense, but we're still very close, but I'm kind of annoyed at her. So that adds a lot more layers to the relationship. And then third, they can communicate and act in an open-ended fashion. So that brings the concept of open world from environment to characters. So open world games introduce this concept of you are free to explore the whole map at any point in the game. There's nothing is hot-locked way. Instead of being soft-constrained by things like your in-game knowledge, your equipment, your skill trees. And now apply that concept to characters. So now you can talk to anyone at any point about anything. So instead of having a scripted dialogue tree where certain options only show up after you complete something, now you can talk to anyone, about anything at one point and just say, and now you're only being soft-constrained by things like you need to know the right thing to talk about, or you need to have the secret information, or you have to have good enough relationship with this person. So let's talk about a more hands-on part of it, working with LLM in practice. LLM in its current state still have a few limitations that can make it quite challenging to work with. So first, it is slow. In game development, it's very common that we optimize for fractions of milliseconds to get that performance. But LLM calls now, it's a few seconds at best, if not a lot longer for more complicated tasks. And on top of that, there's computational cost. So as of right now, it's typically charged per token, which means the longer your prompt or the longer your output is, the more you pay. And then you face the trade-off between how complicated a task you can solve and how much budget you have. So let's look at these two together, because they're the things that it's more out of the hand of game developers. There are ways you can try to improve that, for example, fine-tuning or working with a smaller model, and there's things you can do on the hardware side if you're running in locally. But these are things that usually requires more hands-on experience and deeper understanding of how these model works. So I'm not going to get into the details of how these things work because they change all the time. Like there's prompt caching where if you reuse a prompt, you get priced 1/10 of the original. But these things changes all the time, and having that deeper understanding of LLM is not always the case. So I'm just showing they do exist. But what I want to talk about here is I want to show you the development of LLM in the past 2-3 years. So to translate them into simple language, from top left is cost, how much you're paying, and then speed, how fast it is generating the output, and then context, which is how much information you can feed into one prompt, and then capability, which you can roughly translate to how intelligent they are. So you can see like things are moving very fast, it multiplies every year. And then these are the performance you get by not doing anything. And the numbers is only going to go improve. So while LLMs are not ready for every use case today, I think it's worth to start thinking about what they offer. And when you're ready to go, the technology will catch up. Another one is LLM has a limited context window, which is you have a maximum length of the prompt. So when you're trying to scale to infinite large world or infinitely long gameplay history, it can become quite problematic because you simply can't fit everything into one prompt. A common solution is called retrieval augmented generation, which is the idea is by squeezing everything into one prompt, you keep this information in an external database as a knowledge source. And at runtime, instead of prompting LLM directly, you first use a query to query the knowledge source first and retrieve the relevant information. And you take the retrieved information and combine that with the prompt and feed that to LLM. So by doing that, you can keep an arbitrary amount of information in your external database. And then by focusing only on the retrieved information, which is the relevant information, that also helps large LLM to focus only on the important part, which also helps its performance. And the other thing is, a lot of time what we want to do is we want to take the output from LLM and then feed it to some kind of downstream task or the rest of the game. And then so in order to do that, you need the output to follow a very strict format in order to force the rest of the system to parse that. But LLM naturally generate free-form text. So although we can tell LLM that what the output format should look like, it is not very reliable because it is not trained on data like that. So for example, if you tell it to generate a dictionary that has certain things, it can have missing keys, it can have wrong data types, it can have all kinds of mistakes. So there's two ways to look at this. The first one is if LLM is not good at generating data it's not trained on, then try to stay as much as you can in the domain that it's trained on by rephrasing your question. So for example, we know LLM is good at generating story. We know LLM is not good at generating some parameters that correspond to the mechanism of your game. So say if we want to generate some in-game events that correspond to some parameters in your game, instead of taking a narrative like, oh, there's a natural disaster happened, and then tell LLM to translate that to parameters in your game, it's not going to do well. So instead of doing that, we reverse that by saying you sample the mechanics first. So say characters health -20, spawn monsters, and some plants disappeared, treasure chests disappeared, and then take those and feed it to LLM, say, this is what happened, generate a narrative to explain what is happening here. And then LLM is remarkably good at storytelling from random events, and we'll see more examples later. And then the second is, there are some scenarios where we absolutely needed to generate exactly what we want, which is pretty common. So the providers also start to offer a way to do this. So first of all, JSON mode, which is you can say when you generate something, you can choose to use JSON mode, which guarantee the output to be a valid JSON string. So by doing that, I think there's multiple providers all provide this function. So the content is not guaranteed, but it's guaranteed to be a valid JSON string. And then some packages took it even one step further by constraining the output by token masking, like guidance, instructors, and many more. So how they do this is by for example, if you want the output to be integer, it will mask out all the tokens that is not an integer so that your output is guaranteed to be an integer. But because token masking requires access to the model itself, so it only works well with open source model. It doesn't work for things like ChatGPT or Claude. And then very recently, OpenAI also released this new thing called Structured Output API, which allows you to define exactly what your output can look like. So here's an example. I can say what I want the output to be: a calendar event, which has a name is a string, the date is string, participant, which is a list of string. And when I make the LLM call, I just say the response format should be the calendar event I just defined. And you can see the output here. So the input is, this is the event, and I tell LLM, extract information from this event. And then you can see the output matches exactly what I want. And it's already in the object, so I can just take this object, feed it to any kind of downstream task. Then now it's time to put everything together. So let's make a game, specifically a LLM-powered murder mystery game. So here we choose murder mysteries just because it offers a goal that grounds the game, including the dialogues, interaction, characters, everything, to a very clear goal, which is solving the case. So this helps shows how the story and the character and the world, how they interact with each other, how they are binding together, better than a casual RPG saying, everyone just saying, "Hi, how are you doing?" The thing I'm talking about can definitely be applied to any other game. So this is what we define here. We want an RPG with a murder mystery setting. And to simplify things, we define a 20 by 20 grid map. Everything, including characters, locations, items, are on one tile. There's no rooms or internal structure in the location. Everything is on one tile. And then we define some game mechanism that is suitable for a murder mystery setting. So, for example, you can go to some places, you can talk to people, you can interact with items, and the outcome of interacting with item is defined by item effects. And then this is our game. We start with nothing. So first we need to generate story. So like I said, we need to define the elements in the story. So I say, give me a murder mystery story that has background settings and a time. I want at least 3 suspects. I want at least 10 other characters involved. And to make things more interesting, I say advanced technologies like fingerprint or DNA test doesn't exist. Otherwise, it will generate a story, say, there is a glass of poisoned wine that has a fingerprint on it. It matched this person, boom, case solved. That's a problem. And then so this is the result we get in the winter of 1927. So you can see it immediately pull the time very far back in the past. And then this wealthy Holloway family, blah, 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 and this is what happened. And taking this paragraph, we need to generate the full story, including the characters, the time, the location, what happens, what each character noticed at the time of the incident, and then what they were doing on that day. That all works pretty well until I say, LLM, generate how detectives solved the case. And this is what I got. So inspect the scene, find a key on the floor, talk to the wife, learn about the affair, talk to the lawyer, suggest talk to the maid, learn about the secret letter in the safe, unlock the safe with the key, and then discover the evidence, which sounds like a reasonable story. But if you turn that into a game, this is what happened. You inspect the scene and find a key on the floor, and there's just a safe lying around, so you gotta try, right? And then you find evidence and case solved. So this happens because there's no strict logical dependency between the steps, and which is very important when you're generating something like the puzzle or the quest for the players to solve. So applying what we said before, if it's not good at generating things that is specific to your game mechanism, then try to rephrase your problem by sampling the puzzle first and then fit the story onto it. So here's an example. The top part is that you just by simply sample from the game actions to create the quest. So for example, we start by arriving in the town, and then first thing you do is you talk to A about X, learn about Y. And then you talk to a different person about Y and then learn about something else. So in that sense, it's guaranteed to have that dependencies between them so that you can't do the second step without completing the first one. And then after the end, you need to combine all the information you have in order to solve the case. Then I take this template and then also the story premise and I tell LLM, this is what happened and this is how the detective solved the case. Then generate the full solution, and here's the results. And in that sense, it's guaranteed to have that dependencies. LLM is pretty good at just taking these random events and then generate the thing. And also it scales better because now you can configure how many nodes in the graph or how the minimum path, how many steps you need to take, instead of just relying on LLM and hopefully it remains that logical dependency in a linear fashion. And then after we have the story, we can generate this little intro for our game. And then after that, we have the story. Now we need to generate the world. So we simply extract the locations from the story. And then because pretty much everything happens in that manner, so which is not very interesting. So to make it look like a real village. So I say create more additional common places like market, city hall, parks, etc. And then for each location, we generate details including name, type, coordinates, who lives there, by using the structured output we just mentioned. So it's exactly the dictionary, exactly like what I need. So then, since we have the coordinates, we can start putting the little houses on the map. And then characters, so same thing, we extract the characters from the story, and then for each character we generate details, including name, age, traits, personality, what they do, and then also the relationships. So instead of just saying, this character knows these 5 people, this is my dad, this is my mom, instead of just doing that, we also generate some memories for them. So that helps shapes the relationship. So for example, here's a character that is someone's fiance. So fiance can mean a lot of things. It can be arranged marriage, it can be a couple deeply in love. So by generating these concrete memories helps shape the relationship of what they actually looks like. And now we have the character, we can put this little human on the map. And then move on to game items. So the same thing, we extract the key items I mentioned in the stories, like the evidence, the weapons, things I mentioned. And then on top of that, we need to add more items in the game. So otherwise, all you see in the game is weapons and evidence. So we add a lot more common items to fill the place, and then for each item, we generate the details of them. So the name, the type, the owner, and then of course, we need to generate how we interact with them. And here we take the game actions we defined and also the item effects we defined before for here, and then feed it to LLM, say these are the things you can use, generate how the item interactions. And then now we have the items, we can put it on the map. And then for each location, we generate even more items. And now you can see it start to look like a real game. And now we have everything we need them to start moving. So for example, so in order to make the behavior more coherent and more interesting, we break down the planning into 2 levels. So first we generate the day schedule, which is represented in text description. And then based on that, at real time, we generate the activity, which is some parameters according to the game actions. So here's an example of a local police officer. And you can see starting from sleeping, 6:30, morning routine and breakfast, 7 a.m. I go patrol a village and spend most of the day there. After work, it says I want to go to the library for some reading. And then below is what's happening at during real time. So starting with sleeping, 6:30, it says morning routine and breakfast. So I'm decided I'm gonna make breakfast by interact with the item stove by using cooking. And 7 a.m., I need to go patrol, so I decide I need to travel to my office first. So I say go to in the idea of the office. And after arriving there, it's like, okay, I need to start patrolling, so I just go to a bunch of different places. And after that, in the afternoon, it says, now I'm off duty, I want to go to the library. So first I go to the library, the ID of the library, and after I arrive there, it says I'm going to interact with the item bookshelf by using browsing books. And how these interact with the environment is first they perceive the environment by processing the events from the environment, and they store that in a memory. And after that, optionally, they can do summarize or reflect to form a higher level thinking, which we'll see more examples later. And then you can do planning by you take the observation and generate what you're going to do next according to the schedule. And then you send the action to the game and repeat that process. And then you can do more interesting things like, I want to modify my schedule and respond to what's happening in the game. So for example, there's one time I asked a character, say, can you join me for dinner? I want to ask you some question. And the character agreed. But this thing is not original on their schedule. So in order for that to actually happen, after the conversation, it triggered this replanning to modify the schedule in order to put that later in the day. And you can also do things like, I don't want to stick to a schedule all the time. Sometimes dynamic things happen in the game. So for example, I'm going to go to my office, but I saw someone on my way there and I want to talk to them. So you can perceive the events from the game, say, oh, I see that person is my friend. And you decide, instead of sticking to your schedule, I want to react that by talking to this character. So in that way, that adds a lot more flexibility and a lot more dynamics into the character behaviors. And then here's an example of the memory and the higher level reflection. So on the left, this is what the character sees, like the raw observation from the game. So it's like, I did this thing, I did that thing, I went to this play, I meet these people. And then on the right is, at the end of the day, I can say, take all these information, this is what happened in the day, summarize them. And then you can see it's not more condensed. It only keeps the information, because these are the information that you will forget after 5 minutes, and a lot of them are not actually that important. So by summarizing that, you only keep important information in your memory. And I do want to highlight here, so this is the day of a detective, and then what his day did is pretty much just talking to a bunch of people, finding out the information. And then here you say, this person told me something, and then some blah, blah, and then Evelyn's observation further confirmed the underlying intention. So what happened here is someone told me something. The other person told me the same thing, which confirmed this is true. Or you can have scenarios like this person told me something, the other person told me a different thing, which, that's problematic, but one of them is lying, so I should probably look into this. So this is only possible when you look at a series of events together to form that high-level thinking or deduction. And then so far you can see these behaviors are all generated from character settings and memory, which are all just natural language text, which means if you take this information and then give it to a human, it becomes a human player. And if you take this information and feed it to LLM, it becomes an NPC. So in that sense, the NPC and player creation are interchangeable to the game, and they take the same information and they have the same agency and impact to the game, which means the player doesn't necessarily need to play the detective. They can choose any role in the story and then experience that from the view of that character. So you can have one player playing one role, you can have multiple players claiming different roles, or you can have none of them as players and then just see a bunch of NPCs interact with each other. So for the sake of purpose of the demo, that's what we're going to do. But there's one little problem. So sometimes you need different types of behavior for different NPCs. So for example, for most of the characters here, they're just doing typical role playing, which is doing the thing that matches their personality and their role. But for detective, it has to be a lot more goal-oriented or a lot more purposeful in order to solve the case. So you can simply do that by modifying the prompts. So for example, here's the prompt I used to generate the schedule of the character. I say, generate the schedule of the day for the character based on the character settings and game information. And below is a bunch of information. And for a detective, I simply prepend this paragraph. You're a detective in the murder mystery game. Your most important goal is to solve the case as quick as possible. And then here's the result of before and after I modified the prompt. So I know that's a lot of text. Let me highlight this part. So on the left, it says, investigate the scene and question the resident for details, and put 4 hours there, just question the resident, which makes sense. As a detective, I should spend a lot of time talking to people, interview them. But on the right, you can see 8:30, talk to Emma, the maid who found the body, and then ask her about the timeline of events. And then speak to Margaret about her relationship with the victim, and then look for any signs of guilt or conflict. So you can see the action become very purposeful, very clear. I do this by saying this to figure out what information. It's a lot more goal-oriented, and by doing so, the AI detective was moving forward in the game pretty efficiently. And then at the end of I want to show some example of me playing as detective, messing around with the NPC just to see how they react. And so here's me walking into a character's house at 4 a.m. in the morning. This is day 1, so no one really knows me. I don't really know them. And then I say, I need to ask you questions. And then this is what I got. Groggily waking up and rubbing eyes. Huh? Who are you? What are you doing here? Can we really wait until the morning? I need to sleep now. End the conversation. So you see here, I gave them the ability to start and end the conversation just like players do. So now they can say, I want to sleep. I don't want to talk to you now. And then here's another scenario where I was being rude to the NPC by accusing them, say, are you the murderer? And then without any context. And then this is what I got. Oh, what a starting way to wake someone. I think you're barking up the wrong tree. It's been exhausting for everyone. Good day, detective. And then goodbye. So you can see this, if you're just messing around with the characters and not really trying, they can decide to just say, I don't want to talk to, and then leave. And then one funny thing is, this person is actually the perpetrator in the game. So you can see she's not really falling into the trap of me guiding her to that direction. She's like just glossing over and then blaming back to me, like, why are you bothering me? So I find that pretty interesting. And then you can even make it more interesting when there's multiple characters around. So typically conversation in games is like you talk to someone and back and forth until the end of conversation. But some characters might be close by, they might hear the conversation, they might want to chime in if it's something relevant to them. So I enabled that, and then here's a scenario of me entering a gallery where the victim used to work at, and then there's multiple characters there. So this is what happened. So before I said anything, Henry decided to greet me. He's like, "Oh, detective, wasn't expect you here early. I'm going through a bunch of things. Why are you here so early?" And then I say, "Just checking in. How's everyone doing?" And then Leonard chimed in. He's like, "Oh, yeah, it's unusual to see you for a casual visit. I'm busy. Hope you understand." And then Clara said, "Oh, yeah, I'm doing all right. Thanks for asking. I'm doing some cleaning. Why are you here?" So I started to explain, "I'm here for case investigation. I want to ask you some question. Is that okay?" And they agreed. So at some point, I started to ask them question, and at some point, I was asking Henry, "How would you describe your relationship with the victim?" And then Henry said, "Oh, strictly professional." And I started to talk about work stuff. So I said, "Do you know anyone who's personally closer to her, might know her better?" And then Clara chimed in. He said, "We have friendly professional relationship. We often chatted, but she's quite close to Evelyn Harper." So I looked around. Evelyn Harper was not there. So I said, "I see, but anyone here knows him?" And then Leonard says, "Yeah, as the owner of the gallery, we have frequent interactions, but also professional. So, but like Clara said, so confirming that, she's quite too close to Evelyn. Why don't you talk to her and then leave us alone?" And then so yeah, after that, I went to talk to Evelyn. So at the end, I want to say that this is a technology that is still being rapidly developed. There's a very different working philosophy, very different strengths and weaknesses. And oftentimes the best solution is actually to combine the strength from different technologies. Like we saw examples today, there's word generation with procedure generation, and then you can use LLM to add that personalized touch, or like character behaviors. LLM is pretty good at generating that high-level planning, but you can combine that with algorithms like HTN or GOP to do that more efficient action execution. So I see a lot of opportunities there for LLM to be leveraged into existing pipeline in different ways that brings in new possibility. And that concludes my talk. Thank you very much.